Propagation of longitudinal waves through a medium, the quantity transmitted is. Here, when longitudinal wave propagates, through a medium, the particles of medium oscillate back and forth, but no physical permanent uh, transmission takes place. Only energy transfer takes place in this process. Here, energy stored in an inductor is half Li square. L here is 2 henries. Here it is current is 10 amperes, which is 100 joules. So the inductance of the coil proportional to here. Formula for finding inductance of a coil is L is equal to mu naught mu R n square A by L. So mu naught here is magnetic permeability of free space. Mu R is relative permeability. A here is cross-sectional area. L is length of this. So here it is from this, here it is directly proportional to square of number of turns. So from the formula it is very clear that directly proportional to square of number of turns. Proportional means directly proportional. This is inversely proportional to the length that we will not consider. So here what he is asking, average value of alternating current. So alternating current with respect to time it changes like this. So average value for a complete cycle is total charge per period by total time taken will give you average current. But here it is 0 to t I naught sine omega t dt by t. The sine graph will be like this. For half the cycle it is positive and sine graph is symmetric about x-axis. For remaining half cycle it is negative. So integral 0 to t I dt becomes 0. So electromagnetic waves are transverse in nature, evident by polarization. So here, what is polarization means? It is a phenomenon in which vibrations of a wave are restricted in a direction perpendicular to the motion of a wave. Here, waves for which direction of vibration of particle perpendicular to propagation of wave is known as transverse wave. So hence we say transverse waves of electromagnetic waves, transverse nature of wave transverse nature of electromagnetic wave is evident by the polarization. Here for plano convex lens, lens maker formula 1 by f equal to mu minus 1 by r1 minus 1 by r. For a plano convex lens, for this plane surface, radius is infinity. So 1 by f will be mu minus 1 into, for curved surface, radius of curvature is r. So 1 by focal length he given 10, focal length he given 30, mu minus 1 by 10. So from here mu will be 4 by 3, which is 1.33. In Young's double slit experiment, he is asking what is the distance between slits. Fringe width beta is lambda d by d. So here capital D is 40 centimeters, 40 into 10 power minus 2 meters. Lambda is 6,000 angstrom, 6,000 into 10 power minus 10 meters, which is 6 into 10 power minus 7 meters. Fringe width he given as 0.021 centimeters, 0.01 into 10 power minus 2 meters, which is 1.2 into 10 power minus 4 meters. Small d we can calculate by using the given formula. 6 into 10 power minus 7. Capital D is 40 into 10 power minus 2 by 1.2 into 10 power minus 4. So 10 power minus 4, 10 power minus 3. So it is 24 into 10 power minus 4 by 1.2. this I'll write 12 by 10. 2 into 10 power minus 3 meters, which is 2 centimeters. Here it is here 10 power minus 5. Then here 1.2 into this 10 power minus 3, 10 power minus 5. So 2 into 10 power minus 4 meters, which is 2 centimeters, 0.2 centimeters. So de Broglie wavelength of one de Broglie wavelength is h by p, h by momentum in terms of kinetic energy. Kinetic energy here is 1 million electron volts, 10 power 6 into 1.6 into 10 power minus 19, 10 power minus 13. H value 6.6 into 10 power minus 34. To mass of the proton minus 27 into 1.6 into 10 power minus 30. 6.6 into 10 power minus 34 by, here it is root of 2 into 1.67 into 1.6 into 10 power minus 20. So it is 6.6 by roughly 1.6 into root 2 into 10 power minus 11. Here it is 16 force 64, 4.3 by root 2, which is 1.4, approximately 14. It's 2 point nearer to 3. Only option is this name. The ratio of wavelength corresponding to Lyman and Balmer series in hydrogen spectrum. We use the Rydberg formula. 1 by lambda is equal to Rz square into 1 by N1 square minus 1 by N2 square. So here N1 is principal quantum number of lower energy level. N2 is principal quantum number of higher energy levels. So R is Rydberg constant. And for hydrogen, Z is 1. So 1 by lambda is equal to Rz square into 1 by N1 square minus R. Here, in place of Z, we will substitute 1. We get 1 by N1 square minus 1 by N2 square. We said max longest wavelength means maximum wavelength. So we'll have a maximum wavelength for lower energy, because energy is hc by lambda. So you'll have a energy is minimum, transfer of energy that is possible when wavelength is minimum. Our lambda is energy transfer is minimum, so then wavelength will be maximum. So from first orbit to, in case of Lyman series, uh, here, so energy transfer from outer orbit to first orbit. In case of Bomber series, outer orbit to second orbit. So in case of Lyman series, 1 by 1 square minus 2 square, which is r into 3 by 4. In case of Bomber series, 1 by 2 square minus from lower energy level to higher energy level. In this case, energy transfers will be maximum, wavelength will be minimum. So from first orbit to second orbit, energy is minimum, wavelength is maximum. Here it is lambda 1 by lambda L by 1 by lambda B will be 3 by 4 into, here it is 9 minus 4, that is 5 by 36. So I'll write 36 by 5, 27 by 5. So lambda B by lambda L is 27 by 5. Lambda L by lambda B is 5 by 27. Here, wavelength of an electron according to de Broglie H by 2mk. Energy of photon is Hc by lambda. So here energy, he told same energy. Then here 2mk will be h square by lambda m square. Here kinetic energy will be h square by 2m lambda square. Here energy is hc by lambda. Energies are equal. So this is photon. 2m lambda square is equal to hc by lambda. So from here, lambda p is 2m by c, 2mc by h, lambda m square. These are all constant. Lambda p is proportional to lambda m square. That is first option. Yep. Lambda p is proportional to lambda e square. Here, let me write e square, e square. Okay. Hydrogen, like atom, emits radiations of frequency. So when it makes a transition from n equal to 2 to 1, what is the frequency of emitted in transition from n equal to 3 to 1? So here 1 by lambda is r z square into 1 by n1 square minus n2 square Rydberg formula. Here it is, so he given frequency, hydrogen like atom emits radiation of this frequency, let us say that is n1. So here I will write lambda as c by n1, hydrogen like atom. So 1 by n1 square minus 1 by n2 square. So here it is, n1 is 2.7 into 10 power 15 by c. So when it make a transition from second energy level to first energy level, which is r into 3 by 4. So what is the frequency emitted when it is transmitted from n equal to 3 to 1? That is 9, 8 by 9. So divide one with other. 2.7 into 10 power 15 by n2 here is 3 by 4 into So it is 27 by 30 to 2.7, 10 times. So N2 will be 3.2 into 10 power 15 H. Here, the Brewster angle when a ray incident on a plane surface. So here, reflected ray and refracted ray are perpendicular. So such angle is Brewster angle. Mu1 into sine IP is equal to mu2 into sine R. This is angle of incidence uh, plus angle of incidence, angle of reflection are same. I plus these two are perpendicular. R will be 90 minus IP. So that is mu2 sine 90 minus IP. We get cos IP. So tan IP here is mu2 by mu1. So mu here is C by V2 by C by V1, which is V1 by V2. So V1 here is 3 into 10 power 8 by root 3 into 10 power 8 root 3. So lowest angle is 60 degrees. So here width of forbidden gap of silicon. So for every element energy diagram will be there. So here it is, it's a conduction band. It is valence band. This one is Fermi level. So forbidden gap for silicon is 1.1, 1.1 electron volts. So the Fermi level from conduction band is 1.1 by 2, 0.55 electron volts. So how to get p-type semiconductor? By doping with trivalent impurity. Trivalent impurity, we get p-type conductor. So in this process, this conduction band and valence band energy levels as it is Fermi level initially here, but that shifts to towards valence band. So now your energy gap for forbidden gap between Fermi level and conduction band, energy gap will be greater than 0.55 electron volts. Here, output of logic circuit in the figure is, so here, digital circuit can be made repetitive use of by using this gate. We have different gates, OR gate, NOR gate, AND gate, NAND gate. By using NAND gate repetitively, we get different gates. For example, so this is a NAND gate and followed by a NOT gate. It is an AND gate. With the help of NAND gate, so once you get some input signal to NAND gate, so let us say A, right? A. So this becomes A dot A bar, which becomes A bar. So that becomes a NOT gate. If you take like this, two NAND gates, instead of two, you take three. So you give here input signal as A bar. Your output signal is B bar. So this is A bar, this is B bar. Here it is A bar dot B bar complement output. That is A plus B. So OR gate can be obtained by using NAND gate repetitively. So this many other gates also we can get by using NAND gate. They are universal gates. Here AB. So this output will be A dot B bar. Here it is A dot B bar dot A dot B. Two inputs, so similar inputs. Otherwise, you can write directly this, which is A dot B. So that is the final output X. Here between AB, equivalent capacitance, these two are connected in series. So effective capacitance is 10 plus 10, that is 5 microfarads. So this 5 microfarads and this 5 microfarads are in series. Final effective capacitance, they are in parallel, we added 10 microfarads. A body of mass m is accelerated uniformly from rest. In time t seconds, it attains a velocity v. So v here is u plus at. From this, here u is 0 at. From here I can say as v by t. So instantaneous power is equal to fv. So here I will write v1, let us say. At that point, velocity is v1. So at that point means at that instant of time, initial velocity is 0. So this one power is equal to F. In place of V1, I will write AP. So it is MA into AP. The acceleration is d square by t square of. So mod of A bar plus B bar whole square. A bar minus B bar whole square. Mod A square plus mod B square plus 2A dot B. Mod A square plus mod B square minus, get cancel, plus 2A dot B is 4A dot B 0. Angle between A bar B bar is 5. So here in moving coil galvanometer, we have a rectangular coil having n turns. Here this coil is connected with a screw. When coil deflects, suspension wire is twisted. So here in that process, restoring torque is developed in the wire. So in equilibrium stage, deflecting couple is equal to restoring couple. So here restoring couple is C theta. Here C is this restoring constant. This deflecting couple is NBIA. I here is C by NBA. C constant, restoring torque, N number of turns, B magnetic field, A cross sectional area. All these are constant. This is direct formula. Magnetic field due to infinite wire at a point P here is mu naught I by how much? 4 pi D. It's 2 pi. In fact, if it is a finite wire, alpha beta is there, magnetic field at distances mu naught I by 4 pi D into sine alpha plus sine beta. If it is an infinite wire, this alpha increases alpha 90 as well as beta 90. That is mu naught I by 4 pi D into answer mu naught I by